Okay. For this graph, page 4, example 4. Shh. Well, I should make it lower. Everyone? Okay, y equals to 3 is the c value, so y equals to 3. And the first thing we'll think about the base shape. The base shape, like the base is 4, so I will have increased graph. Okay, increased graph. So then we see the negative. Okay, the negative is on the x. So I will reflect by the y-x-axis. So your shape should be like that. So you have a graph in this shape. So there won't be x-intercept. There's only y-intercept. So you say when x equals to 0, y equals to 4 to the power of 0 plus 3, y equals to 4. So 0, 4 should be the intercept. Okay, now I need to find another point. Which point I'm trying to find? I won't substitute x equals to 1, although it seems quite easy. But have a think, if you substitute 1, 4 to the power of negative 1 is a quarter. And a quarter plus 3 is 3.25. I can't really find the exact value on the grid. So I will do a negative 1. Why I'm doing negative 1? You negative the negative 1, you have 1. So you have y equals to 4 to the power of 1 plus 3. And y equals to 7. Therefore, you have 1 and 7, which is here. Then the shape of the graph is like that. Okay, so 0, 4, and negative 1, 7. But it's nothing wrong if you label 1 and 3.25. It's also correct. Okay, I'm not like really saying you can't substitute 1. You can, but it's just not that easy. Then you can directly find a point on the grid. It gives you the grid, and negative 1, 7 is easy to label. Okay, so that's this one. The domain for this graph will be R, and the range for this graph will from 3 to infinity, small bracket. Okay, that's the answer for example 4. Okay, example 5. Example 5, we have base E. Okay, we have base E. So base E is just a number. It's just 2.7 something. Okay, I don't know what, but like 2.7. So what I can do is I will sketch the XY axis first. Y X. And then I will say 2 is the constant. I'll have 2 here. Okay, y equals to 2. And then we'll have, okay, base shape. Let's see the base. The base is E, so base shape will be increased graph. And then you have negative. Okay, 3 is positive, it's alright. And the negative 1, the negative x minus 1. Okay, negative x. I'm just interested in the negative. The negative is reflected in the y-x-axis. Therefore, the graph will be this. So again, same shape as before, like that. Okay, so what I can do is, when x equals to 0, y equals to 3 e to the power of minus 1 plus 2. I can say that's 3 over e plus 2. Well, 3 over e is 1 point something because it's 3 divided by 2.7. So 1 point something plus 2 is 3 point something. So a little bit above 3. Okay, a little bit above 3. So I can say that's approximated here. It's not necessary to be accurate. And now I need to put another value because there's no x-intercept. If I'm trying to sub another value, okay, I will sub negative 1. Let's see why I substitute negative 1. So when x equals to minus 1, y will be 3e minus 1 is 1. So you have 1 minus 1, which is a 0. So that term becomes a 1. So y equals to 5. Like some negative 1 will be easy. Okay, it will be easy. So negative 1, 5. Okay, the graph will be like this. Okay, that is negative 1 and 5. That is 0, 3 over e plus 2. Okay, do not. Okay, I see a lot of students rounding it. Okay, make it to 2 decimal places. I don't know why. They just want to do it. Like, they think this not looks nice. Yes, that doesn't look nice, but like you still make this to be the answer. Because the question doesn't ask you to simplify it or round it. You can't just find decimal places like 2 decimal places. It's irrational number. E is irrational number. You can't find a definite decimals. So keep your answer like that. Okay, keep your answer like that. Therefore, domain is R. Range is 2 to infinity. Well, I would say the negative 1 will be the best point to substitute because that's the only point can get rid of the e. Okay, that's the only point can get rid of the e and give you a numerical value negative 1 and 5, which is the exact point on the diagram. Okay, last one. Last one. Okay, I will have y equals to 1 as the asymptotes. Okay, y equals to 1. And first, I will say like that's a negative 2ex plus 1 plus 1, like that. So constant is 1. And then e is the base. So the basic shape looks like that. I have a negative here. I will get reflected in the x-axis. So your shape will be like that. Well, the graph can go, say, this way. Okay, positive x-intercept, positive y-intercept. Okay, positive x, positive y. Or the graph can be this. It's still an exponential graph. Negative x, negative y-intercept. Well, it still can go through the origin. There's y-x-intercept and y-intercept. So I need to find where is it, which is very important. So I will make when x equals to 0. Y will be 1 minus 2e. 0 plus 1 is 1, so 1 minus 2e. Is that a positive or negative number? Is that a positive or negative number? Negative. So 2.7. 2.7, 5.4. 1 minus 5.4 is about negative 4.4. Okay, about negative 4.4. Well, it's about here. And I would say there will be x-intercept. You can see, right? There will be x-intercept. So if there's x-intercept, I will make y equals to 0. I don't really interest in another point. When y equals to 0. Okay. 0 equals to, I can say 2ex plus 1 equals to 1. ex plus 1 equals to 2, not to a half. And then x plus 1 equals to log e a half. That's what you have learned in year 10, the last term. And I can say that x equals to minus 1 plus log e half. And that can be x equals to minus 1 minus log e 2. Okay, what's log e half? log e half is log e 2 to the power of minus 1. And I can bring the minus 1 into the front. And that will become a minus log e2. Well, it doesn't matter which one you have. Okay, both answers are correct. Both answers are correct. Well, that's definitely a negative number. Okay, that's definitely a negative number. I'm also interested in another point is making the power to be 0. So when x equals to negative 1, y will be 1 minus 2e to the power of 0. Y equals to minus 1. So you can find another exact point, negative 1 as well. So negative 1, which is here. And then I can use this to complete the trend of the graph. Like this, and this point is minus 1 minus log e2, comma 0. This is minus 1 and minus 1. Not necessary to label this minus 1, I just think it's a good point to label. And that is 0, comma 1 minus 2e. Okay, your asymptotes must be longer than the graph. Okay, asymptotes must be longer than the graph and parallel to the graph in the end. Okay, that's the shape of the graph. So domain for this graph will be R. Range for this graph will be negative infinity to 1, round bracket. Okay, graphing. Okay, after chapter 4, we learn another new graph to sketch. Okay, just have a think about what we need to know. We need to know like hyperbola truncus, circle, square root, cube root, all the polynomial function. In the polynomial, there will be point of inflection form and factorized form. There will be quadratic form, like the turning point form, and factorized form, okay, for cubic and quartic. So all the polynomials we need to know how to sketch it. And now that's after chapter 6. And then in this chapter 13, we have another new graph, exponential. We need to know how to sketch it. Well, you can see based on all the experience we have to sketch graph, I always tell you there's a base shape first. And then any key features is by reflection. There's only 2 ways to reflect it. One is by x-axis, one is by y-axis. And all the movement, I don't really take that into consideration. So the movement, unless it change the asymptotes, we will think about it. For example, this movement is 1, which is changing the asymptotes. We'll move the asymptotes 1 unit up. So that's why we have y equals to 1 sketch first, and then think about all the reflections. Okay, so sketching is easy. Okay, sketching is easy. If you know what you're trying to do, that's easy. Okay, let's go to next page, 13D, page 5. Okay, page 5. I'm pretty sure we have learned this in year 10 as well. I remember I was teaching you that last year. If you have 2 things has the same base and if they are equivalent, which means the power must be the same. Same base, same power, then they are equal. Well, if they have the same base, then the power must be equal in order to make those 2 terms equals to each other. So now I want to solve. That's the first type of solving. So see example 1. I'm trying to solve for this equation. And on both sides, okay, the left hand side I have 4 to be my base already. I will see if right hand side can have a base of 4 as well. So 2, 5, 6. 2, 5, 6. Let's think. 2, 5, 6, and I can divide the 4 first. 2, 5, 6 divided by 4, 64. 64, I'll have 8, 4, and 16, and 4, and 4. There are 4 4s in 2, 5, 6. So 4x equals to 4 to the power 4. And then using the rule above x must be 4. Because they already have the same base, then the power must be the same as well. Okay, next one. Next one I have 5 and 25. Well, definitely can make 5 to each other. Well, like I can do another way, which like let's do an interesting way. Let's see this term. Let's go for 5. I can factorize the top. The top become 2 times x minus 2. And this side still maintain minus x plus 2. And then we can have 5 to the power of 2 first, and then to the power of x minus 2. And this side I still have 25 minus x plus 2. Then I make a base of 25, and x minus 2 equals to 25 minus x plus 2. Therefore, x minus 2 equals to minus x plus 2, 2x equals to 4, x equals to 2. Okay, we have x equals to 2 in this case. Well, I can also make base become 5. Each side I can say that's a 5 to the power of 2, and then times this. And that equals to 5 minus 2x plus 4. I can have that as well. Then will be that number equals to that number. And you solve for it, that's still a 2. That's still a 2. Okay, next one. Next one is 64. 64. 8 times 8 is 64. 8 is 2 to the power of 3 times 2 to the power of 3. That is a 2 to the power of 6. But it's in the denominator. So that is 2 to the power of negative 6. And the denominator, you flip it, is 1 over 2 to the power of 6. So 2 to the power of negative 6. Therefore, minus 3x must be the same as minus 6. X will be 2. X will be 2. Okay, example 2 will be hard to solve. Example 2 is a very typical VCA exam question. It appears a lot in VCA exam. Okay, I can show you the numbers like that appears almost every second year. This type of question will appear in a part 1 or part 2 multiple choice from the exam. So what's this? Well, this is like one type of the question and it's most frequently asked one. So what you can see from this question? You have base 9 to the power of x and you have 3 to the power of x. Well, you can't really start to solve for that because the base is not the same. I don't know where to start. But good thing is 9 and 3 has a relationship which is 2, right? Like 3 to the power of 2 will be 9. So I can first write 3 to the power of 2 x equals to 12 times 3 to the power of x minus 27. Now, again, still not good enough. The next thing is I will swap the order of this x and this 2. Because power to 2 and then power to x is the same as power to x and then power to 2. So it doesn't matter, I can change that. And now I only have 3 to the power of x in this equation. Well, I don't have 9 to the power of x now. I only have 3 to the power of x. Then I will say let a equals to 3 to the power of x. Then that will become a squared equals to 12a minus 27. That is a squared minus 12a plus 27 equals to 0. That becomes a quadratic. This is like changing variables. Okay, changing variables. I change variable x into variable a and changing variables. Therefore, I can have a minus 9 and a minus 3. That equals to 0. Therefore, a will be 9 or a will be 3. But what is a? So 3 to the power of x will be 9 or 3 to the power of x will be 3. So x will be 2 or x will be 1 in this case. Now, this is a very typical type. When you see different base all to the power of x and those two bases are in the relationship of power, like square or cube relationship, you will try to think about this method. Okay, trying to think about this method. All right. Let's have a look at next question. Okay, solve inequality. Solve inequality. This is the type 1 solving inequality problems, which is can become the same base. For both sides. Can become the same base for both sides. For inequality, okay? Equation is easy to solve. Equation will be two types as well. Can be the same base, can't be the same base. But like, doesn't really matter. Equation is really easy to solve. Inequality is a bit hard. Well, if they can make to the same base, okay, make sure the base, make sure the base is greater than 1. Okay, make sure the base is greater than 1. I will tell you why. For example, the base can become a half, or the base can become 2. Make the base to be 2, not a half. Okay, make sure the base is greater than 1 for both sides. You make the same base and both sides base greater than 1. For example, this question, I have 3 and 9. They can become the same base, can become base 3. So 3 to the power of 3x minus 7 greater than 3 to the power of 2 bracket minus 2x plus 8. Okay, same base, different power. Think about 3 to the power of something. What this graph looks like? The graph looks like this. That's 3 to the power of a. Let's say that's a, that's y value. So you want a larger y value. What do you need? You need a larger x. Right? You need a larger a. You need a larger a. The power needs to be larger to get a larger y value. Right? 3 to the power of 4 will be greater than 3 to the power of 3. Therefore, 3x minus 7 needs to be larger than minus 4x plus 16. 7x will greater than 23. X is greater than 23 over 7. Make sure the base is greater than 1. This is the base. Well, can become the same base for both sides. Well, basically both sides can write as like a base to the power of something. I just can compare the power then if the base is the same. Okay, next one. For example, this one. This one is 2 to the power of 4. But the whole thing here is a half to the power of 4. I don't want a half. I want 2. Okay, I want 2. So this can be 2 to the power of negative 3x plus 1 smaller than 2 to the power of negative 4. I want base 2, not half. Therefore, I want the left-hand side power less than the right-hand side power. Then minus 3x will less than minus 5. Okay, I divide by -3. What I should do then? Divide by -3, sign swapped. Okay, sign swapped. So that become greater. That sign swapped. And that's a 5/3. Minus 5/-3, that's x greater than 5/3. Okay, for this one, 27, 3, I can make a 3. So this one will be 3 minus bracket minus 4x plus 2. Okay, minus 4x plus 2 is in the bracket and you minus the whole power to say that's reciprocal. Smaller equals to 3 to the power of 3. Then that's 4x minus 2 will be less or equals to 3. 4x less or equals to 5. X less or equals to 5/4. Why I'm not asking you to do a base less than 1 or in between 0 to 1? Because let's say a graph, let's say if we make that into a third to the power of x looks like decreasing shape. Remember the graph looks different. In this one, the larger the y value, the smaller the x value, right? The larger the y value, the smaller the x value. I need a smaller x value to get a larger y value. The sign is like think different ways, okay? It's not the same as, okay, here is the larger the number, the larger the power, if your base is greater than 1. But when you have a third, for example, I have a third to the power of x less than equals to a third to the power of 2x plus 1. Let's say we have that. And then we need to have x greater or equals to 2x plus 1. I need to have x greater than 2x plus 1 because I need a larger value for this side, so I need a smaller power because the base is a third. The graph looks decreasing shape. Does that make sense? That's no. Okay, so think about 3 to the power of 4 must be greater than 3 to the power of 3, right? 3 to the power of 4 is greater than 3 to the power of 3. Like 3 to the power of anything. If I have a larger number on the power, I must have a larger result. 3 to the power of 5, greater than 3 to the power of 4. 3 to the power of 6, greater than 3 to the power of, like, therefore, I want 3 to the power of something is less than 3 to the power of 3 here. This power must be less than that power. Right? I want to achieve that result. Then that power must be, that whole thing must be less than 3 to get a smaller number. But that's only a power greater than 1. Think about a third. Well, let's say a third to the power of 2 and a third to the power of 3. What's the result? 1/9. What's that? Which one is larger? The sign is like that. The smaller the number, the larger the result, right? The smaller the power, the larger the result. Well, you need to think another way. It's not really follow the sign. You need to swap the sign when you start to compare the power. It's hard. Like you can make mistakes if you put a base which is a third, like or a half or like 3/4. So that's why I keep saying like make the same base and I want the base to be greater than 1. Therefore, you can make sure you don't have like mistakes like swapping sign problems. Like you can just follow what you have for the previous line. Okay. Also, like the shape of the graph, you can see like you need to start to not think about specific values. You need to think about the shape of the graph. That's a third to the power of x. That's y value. That's x value. Y equals to a third to the power of x. If I need a larger value in y, I need a smaller x. For example, -4 will give me a larger value compared to -3. Okay, the y value is higher. The y value is higher. So the smaller the power, the larger the value. From the graph, I can see that as well. Because it's a decreasing graph. That's why I need a smaller number to get a higher y value. Okay. Just if you can't understand, then just remember, I need a base greater than 1. Okay, I need a base greater than 1. Okay, that's exponential solving equations and inequalities, which are really easy. I just need to make the same base and compare the power or equalize the power. Okay, the next thing is logarithm. Well, I have write all these proofs for you. I think I go through in year 10 the proofs, but like I don't think you really need the proof. No one really asks you to prove the law in the exam. You just need to use it. Well, it's make you feel better understanding on this topic if you know the proof. But if you don't, it's okay. What you need to remember is those laws. The first one is this. Second one is that. Third one, well, fourth one is basically the same as that one. Fourth one and third one are the same. Okay, fourth one and same is a simple version for that one. And that one you must know, that's extension. Well, log 5, that's 2 values, you need to know them. And change of base formula, you need to know that. Okay, all the things I have highlighted is all the law for logarithm. Okay, all the law for logarithm. Do not create your own way of calculating like logs. I see a lot of students create their own way. They think, well, based on my experience, I think that's correct. And then they give me an answer, which is like not really using any one of those laws, which is wrong. Log is very different. It has its own way to calculate. It's not really like other exponential or numeric polynomial add subtract. They have own way to calculate. So when you have two log have same base plus each other, you will times those two numbers together. If you have two log same base to subtract, you divide those two numbers. If you have log base m to the power of p, you have a p on the power. You can drag that p into the front and put there p times log am. And number four is basically you drag that -1 into the front, which is the same as law number 3. The p become m. Okay, p become m. Extension we use, well, you may not use it this year, but like this is very important. In year 12, okay, very important in year 12. A to the power of log am will equal to m. For example, 2 to the power of log 2 5, that will be 5. That will be 5. 2 to the power of log 2 5, that will be 5. Or e to the power of log e half, that will be half. Okay, this is a very important, not really a formula, it's just a calculation thing. Okay, it's a really important calculation. I have show the proofs below here as well. Just have a think about it if you want. And law number 5 is log any base of 1 will be 0. Log base of itself will be 1. Okay, that's two special points. Okay, what's the restrictions on A? A belongs to R plus except 1. Okay, A, the base A, the log A, that A needs to be R plus except 1. Okay. Last one is change of base. If I'm trying to change of base, what is change of base? Well, I explained that again is like 10 years ago, we don't have that powerful calculators. You can't put log base anything like our CAS now. We need to change that to a base 10, like where like my mom's age, like they all calculate only base to 10. or like base to a particular base or base 2. So the calculator store all of the base 2 values and you change this number. Okay, now it's base A. I want to change this base A to base 2 and then calculate that. So it's more helpful to use the calculator, or like it's not that powerful calculator. So we have log, for example, we have log to 5. We have log to 5. Let's say the calculator store the value for log 10. I can change that to base log 10. I put the 5 onto the top and I will divide by log base 10 of 2. So this 5 will be on the top and 2 will be bottom. I can change to any base. This 10 can be any number. Can be E, can be 5, can be anything. Our can't be 0 or negative or 1. Like it must still be within the domain of R plus except 1. Anything in that range is fine. That's change of base. Well, like give you a suggestion. In some question, if you don't know what to do for this log, just try to do change of base. You may find your answer. Okay, you may find your answer. Okay, change of base here. Change of base here. Well, this formula is important as well. This like is something you need to remember. That's something you need to remember. Log AB will be the reciprocal of log BA. How do we prove that? How do we prove that? Let's say what log AB equals to. That's base A, right? Base A. I can change that to base B. If I change that to log base B, I will put B here, I will put A here. Well, it's still alright. It doesn't say I can't change to base A. I can change to any base. Well, log base B, log base B. And that is just 1 over log base B A. Okay, that's how this be done. It's just use a change base formula. Okay, just use change of base formula. Okay, change base A to base B. Change base A to base B. Okay, for this one. Okay, log. Okay, what is the base? The base is A to the power of P. And that is B to the power of Q. A to the power of Q and then B to the power of P. Okay, base and the number. Okay, now I want to change it to base A. I don't want to have log base A to the power of P. I want base A only. So I have base A, B to the power of P, and I have log A to the power of Q. That equals to P times log A, B, and Q times log A. And that is P over Q log AB. P over Q log AB. Okay, that's all the theory. Okay, that's all the theory and laws you can have for log. All your calculation will be based on this page. Okay, all your calculation will be based on this page. Have a look at the example 1. Okay, the 3 little examples. Let's say log 381. Okay, 81 is that equals to log 3 to the power 4. And that is 4, check the 4 to the front, you have log 3, and which is 1. That is 4. We use law number 3 and we use law number 5. So that is law, that is law number 3 and law number 5. Check the 4 to the front and then log 3 and 3 just get cancelled. Next one, log E3, well that's 3 to the power of negative 3, and that is just negative 3 times log 3, which is 1 again, that is negative 3. Okay, the last one, I'll just do one last example today. The last example will be this one. Okay, log 349 over log 3 is 343. My question is, can I do that? Can I do that? You just need to say yes or no. Yeah, here. No, why not? Yeah, if you minus them, that's this. But if you divide them, I can't create my own law. Okay, it's just like you have the feeling like you're very likely to do that. Because same base, I just divide those two numbers. Like you want to do that very much, but you can't do this because that's when they subtract. You have this formula. So what I can do to this? Now the next question is what I can do to this. If I can't divide them in that way, what I should do? What's 343 actually? 7 cubed. Okay, if 49 times 7, you have 343. So what we should do is log 3, 7 to the power of 2, divide by log 3, 7 to the power of 3. That is what you need to do for this question. Then you have 2 times log 3, 7 over 3 times log 3, 7. And they get cancelled. Okay, they get cancelled. What we have is 2 over 3 here. 2 over 3 here. Okay, your homework will be finish next page. Okay, finish next page. Okay, finish next page. We have class, right? Yeah.